Hello students, welcome to my YouTube channel. In this video lecture, I am going to solve the new questions from Airborne Weather Radar chapter Key Ingredients. So far I have solved first 30 questions. In this video lecture, I am going to solve the next 10 questions, question 31 to question 40. So let's begin with question number 31. When using Airborne Weather Radar in the mapping mode, in polar areas, one runs the risk of what? Of getting distorted image because of ice reflections, of aurora borealis causing false returns, of underestimating distances because the cold seawater is causing super refraction, making the edge of coastal ice offshore for the mistaking the edge of coastal ice offshore for the real coastline. So the correct answer is option delta. You have to remember that land areas and ice, sheets of ice have similar reflecting properties. Okay, so any return or any radar reflection coming from the ice sheet will be represented on the screen, on the airborne weather radar screen, as a reflection, as a reflection coming from the land surface. Okay, so there is a tendency of mistaking a snow layer or ice layer for a land surface, right? So you may think that the actual ice layer on the ground may be thought to be a land surface. So that is one problem, making the edge of coastal ice offshore for the real coastline. And if there is in polar areas, if there is this sheet of ice layer next to a water body, okay, next to a water body, so this boundary or this coastline, this boundary between the sheet of ice layer and the water body will be thought as coastline, just like when we have land and sea. So the boundary between a land surface and a sea water body is a coastline. So similarly, in this case, this ice sheet of ice will be reflected as a land. Okay, you will think it to be a land surface, and the water body will not be reflected, it will be shown as black. Okay, the return on your radar screen. So if this is your radar screen, something like this. Okay, so you will have a white reflections or white color indication as land and black color indication as water body. So in case you are flying in polar areas where the land surface is covered with ice, snow, so you will mistake that ice or snow to be land surface. And if that ice or snow is thought to be a land surface and there is black color on the radar screen, that will be thought to be that will be an indication of water body. So what you will think, the boundary between them is the coastline, but in reality that may not be that may not be a true fact. Okay, so on the ground the situation may be different. So that is one disadvantage of this, that on the ground there may not be a coastline at all. This water body may have ice sheets of ice layer in submerged in it or floating in it. Okay, and these ice layers may be thought to be land surface, so you have to be careful. They are not actually a land surface or not actually a coastline, but regarded as one. So mistaking the edge of coastal ice offshore for real coastline. Next, question 32. The pictures in the diagram are showing aircraft's position with respect to some thunderstorm cells. So here is the diagram. Now this diagram is not very clear, but here is your aircraft, and there are two heavy returns, red color returns coming from cloud. And this is a heading 180. There is a cloud, there is an indication or radar indication 30 degrees to the right hand side, and there is another indication 30 degree to the left hand side of your true heading. Next. So, and the image the pilot is getting from the radar. To detect this blind alley, the pilot should what? So, blind alley. What is blind alley? Blind alley is nothing but the gap. You can see there is a gap between these two cloud returns. So that gap, the way through them is called blind alley. The gap between the two cloud returns. Okay. The gap between two cloud returns. So the answer to this question is to detect this gap or to detect the way through this cloud return, you will have to increase the range setting of the radar. You will have to increase the range setting of the radar. What happens when you increase the range setting of this radar? So you will get to see you will get to see a picture which is much beyond this range. Now currently the range display on your screen is this is 20 nautical miles. This ring is 30 nautical miles. Okay. And the next ring will be 40 nautical miles. So when you increase the range, you will get to see a picture or you will get some idea of distances much beyond 40 nautical miles. So you will get to see whether there is any kind of weather beyond this 30 nautical mile range. 30 nautical mile range is where you're finding these two kinds of weather returns, cloud returns. So by selecting the range to a higher setting or a higher level, you will get a broader picture and whether you can go through this blind alley or through this way. And if you're going to encounter any other weather beyond this range, because these two radar returns may be in real atmosphere something like this. This is what we are getting to see on the radar screen, but we are not getting to see anything beyond that. Okay, so to get a broader picture, you increase the range, so you will get to see or you will get an idea of what's happening beyond 40 miles at 50, 60, 70. So when you do that, it may be the case that these two cloud returns are a part of much larger cloud development like this, something like this. Okay, like this. But this entire thing is not shown here. What we see is these two circles here. So to get a broader picture or more information, we increase the range so as to confirm our doubts. Okay, so the correct answer is to increase the range setting of the radar. Question 33. Is it possible for weather radar to be operated on the ground? Yes, it is possible to be operated on the ground, but you have to take care. You have to take care, precautions, and follow all the regulations set by the manufacturer, your company, the regulatory authority. Because this weather radar operates in the frequency band of super high frequency, and this frequency is harmful for ground personnel. Everyone on the ground, this frequency is harmful for their health. Second, there is a danger of fuel vapor ignition if you operate this airborne weather radar on the ground. The third danger is that the airborne weather radar may get damaged from the strong returns or reflections from nearby objects. From nearby objects. Okay. So remember these three things. So the correct answer here is yes, you can operate it but follow all regulations, guidelines, precautions. Next. Question 34. In which frequency band do most airborne weather radar operate? Now, airborne weather radar is a type of primary radar. Okay. It is used for two purposes. First, detect weather, and for second is navigation purpose. We called it ground mapping. The frequency that is used is 9.375 gigahertz, super high frequency band, centimetric wavelength, centimetric wavelength. Now this 9.375 gigahertz can also be written as 9375 megahertz. Normally the wavelengths are 3 centimeter or also 30 millimeter. 3 centimeter is nothing but 30 millimeter. So remember that. Next. Question 35. The theoretical maximum range for an airborne weather radar is determined by what? Always remember, maximum range is always determined by pulse repetition or pulse recurrence frequency. Minimum range is determined by pulse width. Is determined by pulse width. Now what happens? Let's say this is your transmitter. Okay, this is your transmitter. When this transmitter transmits a radio pulse in the direction of this aircraft, which is its target, okay, so this is the pulse that is sent. Okay, so this pulse will go in the direction of the target, strike that target, and return return to the receiver. After it comes back at the receiver, the next pulse will start. The next pulse will be sent. Okay, so there should be, the reason is there should be sufficient time delay between consecutive pulses. Okay, new pulse must be sent after reception of the previous pulse. Okay, therefore maximum range is inversely proportional to pulse recurrence frequency. That's it. Minimum range is pulse width. I have explained this in more detail in the lectures based on ground radar, basic radar principles. So I have also solved those questions in that video lectures and explained that there also. So do watch that lectures too. Next, question 26. Correction, question 36. On the airborne weather radar display in weather mode, different colors are used for what? So remember, different colors are used to display different intensity of precipitation. Option A says to display ground height differences, to display echoes from other aircraft, to display clouds indicating different levels of visibility. So the correct option is option Charlie. We use colors to classify precipitation intensities. Black color is used for very light or no returns. Black color is used for very light or no returns. Next, green color is used for light returns. Yellow color is used for medium returns. Red color or red magenta is used for heavy returns. So these colors in turn determine the intensity of precipitation, how severe it is. So the option is option Charlie, to display different intensity of precipitation. Ground checks of airborne weather radar are what? Are allowed only when aircraft has undergone servicing, allowed under specific health and safety regulations, unrestricted, prohibited at all times. So the most appropriate option is option Bravo. Like I said previously, airborne weather radar can be operated on ground provided you abide by, okay, you fulfill all guidelines, regulations, company manufacturer recommendations. So take care of that. Next, question 38. The airborne weather radar can't detect snow, wet hail, dry hail, and moderate rain. So what can it not detect? The correct option here will be snow. So it can readily, very willingly, and perfectly efficiently detect wet hail, followed by rain, then ice crystals, then wet snow, then dry hail, and then dry snow. So wet hail is most reflective. So that is wrong. Moderate rain. Yes, rain is also reflective. So that is also wrong. Now the options are snow and dry hail. So between dry hail and dry snow is the least or less reflective. So the correct option here will be option A. It cannot detect, okay, it can't detect or barely detect snow. Okay. Question 39. Which of the following list of phenomena are least likely to be detected by airborne weather radar? Okay, similar question. Clear air turbulence, precipitation, turbulence in cloud that has precipitation, wet snow, and turbulence in cloud that has precipitation. So correct option here is option A. Clear air turbulence, wake turbulence. These are two types of turbulence which your airborne weather radar cannot detect. It can detect precipitation. Precipitation is nothing but your wet hail, rain, ice crystals, dry hail, dry snow. Okay. Turbulence in cloud that has precipitation. The main purpose of airborne weather radar is to detect turbulence, but it cannot detect turbulence directly. So it detects large water droplets in the clouds, and these large water droplets are nothing but indications of heavy turbulence present in the cloud. So yes, it detects turbulence but indirectly. Again, wet snow and turbulence. Yes, as we saw here, wet snow can be detected by airborne weather radar, and from that, the pilot can interpret or derive information as to turbulence in cloud. The correct option is option A. Clear air turbulence and wake turbulence are not indicated, okay, or are not detected by airborne weather radar. Question 40. While using airborne weather radar in weather mode, the strongest returns on the screen indicate what? The strongest returns. Areas of severe icing? No. Areas of probable wind shear? Again, just like clear air turbulence and clear air turbulence, wake turbulence, wind shear also cannot be detected by airborne weather radar. So option Bravo is also wrong. Areas of high concentration of large water droplets. That is right. Areas of severe turbulence. So that is wrong. Strong returns indicate areas of high concentration. You will get strong returns or strong reflections from any area where there is heavy concentration of water droplets, and this in turn indicates turbulence in that area. Okay, but directly, first direct indication of that is areas of high concentration of large water droplets. And then you derive or you interpret that information as presence of severe turbulence in that particular area. This option, Charlie, is the most appropriate option. Next. So this concludes our lecture. I hope you have understood all the 10 questions I have answered and explained. Practice these questions again and again. I suggest you also practice questions from Oxford and RK Bali as well. I have done the questions from that chapters and uploaded it to my YouTube channel. Do watch that video lecture. Thank you for your time. Subscribe to this channel, share this video with your friends, and please like the video lecture. I'll see you in my next video lecture.